Today, explore the top 30 greatest mathematical equations and formulas that changed the world. Discover the groundbreaking equations and timeless formulas that revolutionized mathematics, science, engineering, and human civilization. Introduction. Welcome to LSKSM Vlogs. Today, we explore the top 30 greatest mathematical equations and formulas that changed the world, discovering the powerful ideas that revolutionized mathematics, science, engineering, and technology. From geometry and algebra to physics and finance, these timeless formulas continue to shape our modern world. One. Pythagorean theorem. Person, Pythagoras, century 570 to century 495 BC. The Pythagorean theorem relates the three sides of a right triangle and is one of the foundations of geometry. It is widely used in mathematics, engineering, architecture, and physics. 2. Quadratic formula. Person, Al-Khwarizmi, century 780 to 850. The quadratic formula provides a universal method for solving quadratic equations. It is essential in algebra, engineering, and scientific problem solving. 3. Slope formula. Person, Pythagoras, century 570 to century 495 BC. The slope formula measures the steepness and direction of a straight line. It forms the basis of coordinate geometry and graph analysis. 4. Distance formula. Person, Pythagoras, century 570 to century 495 BC. The distance formula calculates the shortest distance between 2 points on a coordinate plane. It is widely applied in geometry, navigation, and computer graphics. 5. Circumference of a circle. Person, Archimedes, century 287 BC to century 212 BC. The circumference formula determines the distance around a circle using its radius or diameter. It is fundamental in geometry, engineering, and design. 6. Volume of a sphere. Person, Archimedes, century 287 BC to century 212 BC. This formula calculates the space enclosed within a sphere. It has important applications in physics, astronomy, and engineering. 7. Area of a circle. Person, Archimedes, century 287 BC to century 212 BC. The area formula measures the surface enclosed by a circle. It is one of the most widely used formulas in mathematics and science. 8. Euler's identity. Person, Leonhard Euler, 1707 to 1783. Euler's identity is celebrated as one of the most beautiful equations in mathematics. It elegantly connects several of mathematics' most fundamental constants. 9. Euler's formula. Person, Leonhard Euler, 1707 to 1783. Euler's formula links exponential functions, trigonometry, and complex numbers. It plays a vital role in engineering, physics, and signal processing. 10. Binomial formula. Person, Isaac Newton, 1643 to 1727. The binomial formula provides a systematic way to expand powers of binomials. It is widely used in algebra, probability, and combinatorics. 11. Maclaurin series. Person, Colin Maclaurin, 1698 to 1746. The Maclaurin series represents functions as infinite polynomial expansions around zero. It is fundamental in calculus and numerical analysis. 12. Fourier series. Person, Joseph Fourier, 1768 to 1830. Fourier series expresses periodic functions as sums of sine and cosine waves. It revolutionized signal processing, acoustics, and electrical engineering. 13. Taylor series. Person, Brooke Taylor, 1685 to 1731. Taylor series approximates complex functions using polynomials around a chosen point. It is essential in calculus, physics, and engineering. 14. Fourier transform. Person, Joseph Fourier, 1768 to 1830. The Fourier transform converts signals between time and frequency domains. It is indispensable in communications, image processing, and quantum physics. 15. Normal distribution. Person, Carl Friedrich Gauss, 1777 to 1855. The normal distribution describes how many natural and statistical data sets are distributed. It is one of the most important concepts in probability and statistics. 16. Compound interest formula. Person, Jacob Bernoulli, 1654 to 1705. The compound interest formula calculates the growth of investments by earning interest on both the principal and accumulated interest over time. 17. Logistic growth equation. Person, Pierre-François Vuilhelst, 1804 to 1849. The logistic growth equation models population growth with environmental limits. It is widely used in biology, ecology, and economics. 18. Bayes formula. Person, Thomas Bayes, 1701 to 1761. Bayes formula updates probabilities based on new evidence. It is a cornerstone of statistics, artificial intelligence, and machine learning. 19. Newton's second law. Person, Sir Isaac Newton, 1643 to 1727. Newton's second law explains how forces produce motion and acceleration. It is one of the fundamental laws of classical mechanics. 20. Universal law of gravitation. Person, Sir Isaac Newton, 1643 to 1727. Newton's law of gravitation describes the attractive force between all masses. It laid the foundation for celestial mechanics and modern physics. 21. Schrödinger equation. Person, Erwin Schrödinger, 1887 to 1961. The Schrödinger equation describes the behavior of particles in quantum mechanics. It is central to modern atomic and molecular physics. 22. Maxwell's equations. Person, James Clerk Maxwell, 1831 to 1879. Maxwell's equations unify electricity, magnetism, and light into a single theory. They are among the most important equations in physics. 23. Ideal gas law. Persons, Émile Clapeyron, 1799 to 1864. The ideal gas law relates pressure, volume, temperature, and the amount of gas. It is fundamental in chemistry, thermodynamics, and engineering. 24. Wave equation. Person, Jean-Le Rond d'Alembert, 1717 to 1783. The wave equation describes how waves travel through different media. It is widely applied in acoustics, optics, and electromagnetic theory. 25. Einstein's mass-energy equation. Person, Albert Einstein, 1879 to 1955. Einstein's famous equation revealed the equivalence of mass and energy. It transformed modern physics and led to advances in nuclear science. 26. Black-Scholes equation. Persons, Fisher-Black, 1938 to 1995, Myron-Scholes, 1941 to 1995. The Black-Scholes equation provides a mathematical model for pricing financial options. It revolutionized modern finance and investment theory. 27. Navier-Stokes equations. Persons: Claude Louis Navier, 1785 to 1836, and George Gabriel Stokes, 1819 to 1903. The Navier-Stokes equations describe the motion of fluids such as liquids and gases. They are fundamental to fluid mechanics and engineering. '28. Lorentz transformation. Person: Henrik Anton Lorentz, 1853 to 1928. The Lorentz transformation explains how space and time change for observers in relative motion. It became a key part of Einstein's theory of relativity. '29. Drake equation. Person: Frank Drake, 1930 to 2022. The Drake equation estimates the possible number of intelligent civilizations in our galaxy. It remains an influential concept in astronomy and the search for extraterrestrial life. '30. Shannon's information formula. Person: Claude Shannon, 1916 to 2001. Shannon's information formula established the mathematical foundation of information theory. It transformed digital communication, data compression, and modern computing. Conclusion. Thank you for watching Top 30 Greatest Mathematical Equations and Formulas That Changed the World. We hope this journey through history's most influential mathematical discoveries has inspired your curiosity and appreciation for the formulas that transformed human knowledge. Don't forget to like, share, subscribe, and press the bell icon for more fascinating educational videos from LSKSM Vlogs. These videos are not only for the current generation. They are a humble effort to preserve knowledge, history, science, and human achievements for future generations. Thank you to everyone who supports and encourages this journey of building a digital library of learning for tomorrow. If you enjoyed this video, please subscribe to the LSKSM Vlogs channel, like, comment, and share it to help pass on knowledge to future generations. Your support and encouragement mean a lot to us. G. Sobhanadri Rao, LSKSM Vlogs.